Now this is a very important theorem, that is factor theorem, and it is just an extension of the remainder theorem. Now let us understand what is this factor theorem. Of course, it is a method of factorization. So let us see what is the theorem. A polynomial p of x divided by x minus a has remainder p of a is equal to 0. This is a remainder theorem. A polynomial p of x divided by x minus a has a remainder p of a equal to p of a. The remainder is p of a. But again, if p of a is equal to 0, then x minus a is a factor of p of x. This is there are two theorems involved here. Please understand, we have the remainder theorem first, and then we extend the remainder theorem to get the factor theorem. Now again, I'll repeat: a polynomial p of x when divided by x minus a, the remainder is p of a. But if p of a is 0, then x minus a is a factor of p of x, and remember that. So now let us take to understand this theorem, let us take an example. Now p of x is equal to x cube plus 3x squared plus 5x plus 6, and we have a binomial x plus 2 here. Now let us find out whether x plus 2 is a factor. Now what we do here, to find out the 0 of x plus 2 first, the 0 of x plus 2 is x plus 2 equal to 0 or x is equal to minus 2. X is equal to minus 2 is the 0. Now find out p of minus 2. If you find p of minus 2, then put wherever x is there minus 2. So we got minus 2 cube here, 3 into minus 2 square plus 5 into minus 2 plus 6. Simplify it, we get minus 8 plus 3 into 4 minus 10 plus 6, minus 8 plus 2 minus 10 plus 6, minus 18 plus minus, that is 0. That means if p minus 2 becomes 0, then x plus 2 is a factor of this. That means we have verified, or we have found out, that x plus 2 is a factor of x cube plus 3x squared plus 5x plus 6. So remember this is the method of finding out whether a given polynomial is a factor of another polynomial. Remember that. Okay. Then coming to the next very important application, that is application of factor theorem. Now here we are asked to factorize x cube minus 3x squared minus 9x minus 5. It is not easy because it is a cube term. Now we cannot apply we can apply other methods, but we have to first apply the factor theorem. So let us see how to do that. If x minus a, x minus b, x minus c are the factors, because it is a cube term, that means there have to be three factors, x minus a, x minus b, x minus c. Then we find that the constant term is minus into minus is plus, plus into minus is minus, that is minus abc. The constant term of multiplication of these three factors is minus abc, and the minus abc here is minus 5, therefore abc is 5. If ABC is 5, then the factors of ABC, the factors of 5 will be plus minus 1 or plus minus 5. So ABC are factors of 5, and the factors of 5 are plus minus 1 plus minus 5. So now we have to test whether we have to find out which value of ABC. For what value of ABC the p of x will be 0. So let us take the first value, that is p of plus 1. When we put x as 1, we get the p of x is not equal to 0, or p of plus 1 is not equal to 0. Therefore it is plus 1 is not a factor, or x minus 1 is not a factor. Now then we will go for p of minus 1. When we put p of minus 1, wherever x is there, put minus 1. Therefore minus 1 cube, we simplify it, we get p of minus 1 as 0. If p of minus 1 is 0, then x plus 1 is a factor. Now if you put p of find p of 5. Find p of 5. Wherever x is there, put 5. Again we get p of 5 is equal to 0. That means x minus 5 is a factor. So now by inspection we have found out that x plus 1 is a factor and x minus 5 is a factor. Okay, and now but we need one more factor, and for that what we will do, we will multiply the two factors x plus 1 into x minus 5. Since the x plus 1 is a factor, x minus 5 is a factor, the product also is a factor. Therefore x plus 1 into x minus 5 is x squared minus 4x minus 5. Therefore this is also a factor of this. If this is a factor of this, when I divide this by x squared minus 4x minus 5, the remainder has to come 0. Let us see how it is done. Let us go by long division method. So when I divide x cube minus 3x squared minus 9x minus 5 by x squared minus 4x minus 5, we find that we get the quotient as x plus 1. Therefore x plus 1 is the quotient, and x plus 1 is a factor of the third factor of this polynomial. So in all, x cube minus 3x cube minus 9x minus 5 has three factors, and the factors are the x plus 1, x minus 5 and x plus 1. So these are the three factors. It's a very important method, so learn this to understand or practice this so that the method is clear. So let us see how we can go for and learn another example. Now let us say we have an example here, that is x cube minus 23x square plus 142x minus 120 is p of x. Now we have to factorize this. It's a cube term, that means there are three factors, and the factors can be x minus a, x minus b, x minus c, and the constant term here is minus a minus b minus c. That means minus a, minus into minus is plus, plus into minus minus, that is minus abc, and minus abc is minus 120, or abc is equal to 120. The factors of 120 are plus minus 1, plus minus 2, plus minus 3, plus minus 4, and so on. Now let us find out the value of x for which p of x is equal to 0. So let us start with p with plus 1. So p of 1, we find it is 0 by putting the value of x as 1 in this polynomial. We find that p of 1 is 0, therefore x minus 1 is a factor. And if we find that x minus 1 is a factor, now it becomes very simple. Divide this by x minus 1, then since it is a factor, it will completely divide this, and we get a quotient, and that quotient is x square minus 22x plus 120. I have already taught you how to go for long division method of dividing the polynomials. So divide the polynomial by x minus 1, we get the remainder as 0, and the quotient as x square minus 22x plus 120. Now express p of x. This is p of x here. Now it is a product of two very important factors, and that is one is x plus that is x minus 1, and the other one is x square minus 22x plus 120. So it is a product of that. Now we have x minus 1 as one factor. Now it is a second degree polynomial. We can go for middle term splitting method, and when we go for middle term splitting method, we find that x square minus 22x plus 120 can be split as minus 12x minus 10x. Then go for grouping. When we group it, pair it, and take common here. X is common in the bracket x minus 12, minus 10 is the 10 is common, minus 10 in the bracket x minus 12, and here we have x minus 12 common, so x minus 12 in the bracket x minus 10. So we find that the three factors of the given polynomial are x minus 1, x minus 12, and x minus 10. So that is how we can apply the factors theorem for finding out for carrying out the factorization. Remember that. Now again we have to learn another very important property, that is HCF and LCM of polynomials. Now what is the HCF? Highest common factor. Now to find out the highest common factor, we already know what is highest common factor. So first of all we have to find the factors of these, and then take the one which is common. For example, x cube, the factors of x cube are x square and x cube, and factors of x square is x and x square. X is common, x square is common, but we have to take the highest common factor. Therefore HCF of x cube and x square is x square. Let us take one more example. Now we want to find HCF of 6x square y 8xy square. Now here find the factors of 6x square y. The factors of 6 are 1, 2, 3, 6. Factors of x square is x square, and factor of y is y. The factor of 8xy square will be 1, 2, 4, 1, 2, 4 and 8, and factors of x is x, y square is y, and y square. Now what is common in this? 2 is common, x is common, y is common. Therefore HCF of 6x square y and 8x square y square is 2x and y. So that is what is the method of factors, that is the factors method of finding HCF. Now let us take one more example. We want to find out the HCF of 30x square minus 3x plus 2 and 50x square minus 2x plus 1. Now first of all let us write down all the factors of this. 30 factors are 2, 3, 5, and x square minus 3x plus 2 is an algebra with a second degree polynomial. There are three terms here. We can factorize it by middle term splitting method. The method is 2 into 1 is 2, and when I multiply I should get 2, when I add I should get minus 3x, and therefore splitting we get x square minus 2x minus x plus 2. Then pair it, group it, and take common. That means we can group it as x, pair it here. X is common, x minus 2, minus 1 is common, x minus 2. Then what is common here? X minus 2 is common, and x minus 1, and therefore the factorization of this 30 in the bracket x square minus 3x plus 2 will be 2 into 3 into 5 in the bracket x minus 2 and x minus 1. Same way factorize the next 50 x square minus 2x plus 1 here. That is 50 becomes 2 into 5 into 5, and the factors of x square minus 2x plus 1 by middle term splitting method will be x minus 1 into x minus 1. Now take what is common in this. The common is 2 and 5, so 2 and 5, so HCF is 10. And what is common in the algebraic terms here? X minus 2, x minus 1, x minus 1, x minus 1, so x minus 1 is common. Take x minus 1, therefore 10 in the bracket x minus 1 is the HCF of the given two algebraic expressions. Remember that. Now LCM is least common multiple. Again we can go for factors method of finding LCM. X square becomes the multiples of x square are x square, x cube, x4 dot dot dot, because there are infinite multiples. Similarly, multiples of x are x square, x cube dot dot, and now the least common multiple here, if you find the common is x square and x square, that is therefore the least common multiple between x square and x is x square, and therefore the LCM of x square and x is x square. Remember that. Now we also can go for the long division method to find the LCM of 5xy square and 8x square yz. Now write them in a column here. Now what is common here? Start with what you call 5 1 the 5, 8 as it is, then 8 1 the 8, then take x goes here, xy square, and here x square yz. So we have xy square and x square yz. Now we can divide by x here, x on the x, y square as it is, x on the x will remain, x square minus 1 is x, yz here, then divide by x again, x will go, yz will remain, divide by y, we get y remains and z remains, again divide by y, only z remains, and divide by z we get 1 and 1. So therefore now the LCM will be 5 into 8 is 40, x into is x square, y into y is y square, and z. A very simple method. Try to remember this. We have learned this when we were finding the LCM of numbers. Now here, to find the LCM of x square minus 4 into x cube and x cube minus 8. Now x square minus 4 becomes x square minus 2 square, then this is a square minus b square form. It is x plus 2 into x minus 2 by applying the identity a square minus b square is equal to a plus b into a minus b. Now x cube minus 8 is x cube minus 2 cube. Now use the identity a cube minus b cube, that is a minus b in the bracket a square plus ab plus b square. Therefore x minus 2, x square plus 2, x plus 4 are the factors of x cube minus 8. Now compare the factors here. We have got x plus here x minus 2 is common, take x minus 2, and therefore the remaining terms are x plus 2 is remaining, x square plus 2, x plus 4 is remaining, and therefore the LCM is x plus 2 into x minus 2 into x square plus 2, x plus 4, and that is x square minus 4 in the bracket x square plus 2, x plus 4, and this is the LCM. So in LCM, first of all we find the HCF and take the remaining terms. So HCF is x minus 2 and the remaining terms are x plus 2 and x square plus 2, x plus 4, and take the product of them, we get the LCM. So remember this method of finding LCM of polynomials. So this is what is the study of the factorization and the finding methods of finding HCF and LCM of polynomials. Please go through this again and again, understand the procedures, understand the properties, and these are important basics in algebra. Okay, thank you.